morning everyone, welcome back to my channel. Now we'll be working on 3-bit asynchronous up counter. We'll quickly talk about introduction. Counter. What is counter? A sequential circuit. A sequential circuit which helps you to count number of events. 3-bit means mod 8 counter. 3-bit means it will count 8 states. The states will be 0, 1, 2, 3, 4, 5, 6 and 7. If you count, they are total 8 states. Now, next thing to be kept in mind is we are using asynchronous. Asynchronous means clock needs to be finalized. There are two types of clock, positive and negative. When I want to use positive clock, and there are two types of outputs, Q and Q bar. Positive makes down counter. Positive, negative makes up counter. Negative, positive makes up counter. Negative, negative makes down counter. So we'll be using negative clock pulse to design the counter. Now, number of flip-flops required will be 3. Why? Because we are making 3-bit asynchronous counter. And because we are making up counter, so we will be using negative flip-flop. So quickly make 3 blocks. Which type of flip-flop we are using? T. So name them as TA, QA, QA bar, TB, QB, QB bar, TC, QC, QC bar. Now, T should be high. So every T is made high, and high means T is equal to 1. Next comes the concept of clock. Now, when I say clock is always given to the first flip-flop, and I am opting for negative clock. Now, output of first flip-flop acts as clock to second. Output of second flip-flop acts as clock to third. And the total output we fetch from every flip-flop is QA, QB, QC, where QC is the MSB and QA is the LSB. Now, next step is the timing diagram. Now, let's quickly make the timing diagram. Bare minimum, make 7 to 8 clock pulses so that you can see the output nicely. Then we are using negative edge triggered, so let's mark the negative edges of this clock pulse. Negative edge or fall edge is the place where every flip-flop will change its state. In our circuit, we have 3 flip-flops. QA will change its state depending upon the external clock pulse. QB will change state depending upon negative edge of QA. QC will change its state on negative edge of QB. Now, first we'll make the first output, that is QA. QA changes its state at negative edge. At every negative edge, it will change its state from 1 to 0 and from 0 to 1. That is, the system toggles. Now, when we have the very first clock pulse, we need to mark its negative edge. This is the negative edge of QA. QB will change its state at negative edges of QA. So, the timing diagram of QB is as follows. Then comes the turn of QC. QC will change its state on the negative edge of QB. So let us mark the negative edge of QB. Now the turn of QC. Now let us take the values. It is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. If I write it as MSB, it is QC, QB, QA. The sequence, if we write it as, it is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, triple 1. How many states? 8 states. Type of counter? Mod 8. Asynchronous up counter. That's all for today. I'll be soon coming with a video on asynchronous down counter category. Thank you.